Let's do another example of an induction problem because it never hurts to have another example. In this example, we're going to prove that 4 to the third plus 4 to the fourth plus 4 to the fifth up to 4 to the n is going to give you this expression, 4 times 4 to the nth power minus 16 divided by 3. I'm not going to do it right now, but what you might want to do is to try to work through the first couple cases. Sometimes that's a useful thing to do. It usually makes it so your base case falls out, and it can give you some hints into the algebra that might be involved for the rest of it. So try doing this for 4 to the third and 4 to the third plus 4 to the fourth and so on. Now it might help to think about how this looks when we do this with the summation notation. What do we have here? Well, you know you're going to be working with 4 to the power of I. But the question is, where does it begin? Does it begin at 0 like some of the ones we've done? Or perhaps at 1? But if you look at this sequence really starts with an I that starts at 3 and goes to n. So it's a little bit different here. That changes what we're using for our base case. So you see on this one, our base case starts at 3. So what we're doing is we're going to look at when we start at 3 and finish at 3. So we're just looking at 4 to the third. Now 4 to the third is 64, which is really the left-hand side of our expression. Let's look at it when we are using the formula, however. When we use the formula, we're going to have 4 times 4 to the third minus 16 over 3. Which is what? 4 times 48 divided by 3, which also works out to 64, so both sides are the same. We are now ready for our inductive case. In our inductive case, we have to assume that n equal to k is true, and we're going to show that n equals to k plus 1 is also true when this is true. So when we assume that, what does that mean? We're going to assume, let's try writing this, well, let's do it with the summation symbols at first. We're going to assume that when we start at 3 and go to k, looking at 4 to the I, that's equal to 4 times, we have to put in a k into our formula, 4 to the k minus 16 over 3. Now what we have to show is that when n is equal to k plus 1, so we have k plus 1 up here, but we're still starting at 3, 4 to the I, that it's going to give us 4 to the, now substitute in k plus 1 where we had the n before, we get this expression. Alright, so what are we going to do? We're going to take the left-hand side of this and say now, and why don't we write this in the expanded form so you can see what's going on. It says 4 to the third plus 4 to the fourth plus 4 to the fifth plus 4 to the sixth plus, all the way out here, the last one's going to be 4 to the k plus 1. Remember the term before that is 4 to the k. Well, this expression right here is the same as what we were assuming. So we can substitute this into its place. So we have 4 times 4 to the k minus 16 over 3 plus 4 to the k plus 1. And what we have to do is show that this expression that we've just gotten here is the same thing as this. So once again, we're going to have to add these two things together, so we need a common denominator. Here, let's multiply these together. 4 to the first times 4 to the k is going to give you 4 to the k plus 1. Then we're going to have 4 times, how do we want to write it? 4 times the 16, should we write it as minus 64? That's all over 3. Over here, we need a common denominator of 3. So we're going to have to multiply 3 times 4 to the k plus 1. Okay. Notice something. We have 4 to the k plus 1 here, 4 to the k plus 1 here. When I add these together, my denominator's 3, I have 1 of these factors, 3 of these factors, so I have 4 of those factors all together. All right. Minus 64. So I have 4 being multiplied times this, and another 64 being subtracted. But the 64 has a factor of 4 that is in it. So I can rewrite this as 4 to the k plus 1 minus 16 as a binomial here. And I get this, which is what we were trying to show. So we've done the inductive step. So we can say, by the principle of math induction, we know that the sum starting from 3 going to n of 4 to the I is going to work out to being that formula. Sorry, I can't quite fit it in there, but you know what it is from the top. I hope seeing another example is helpful.